mistake. So when it comes to these videos, overall, we are discussing about second order differential equations. But actually, we are discussing second order linear differential equations. So in other words, I forgot to add a word linear to the main discussion for these videos. Okay. So basically, from the first video I made, which is about second order differential equations, homogeneous, right? Up to now, they're all linear. Okay, so overall, this is all about second order linear differential equations. So we can now begin to the discussion for today. So our topic for today is basically getting the solution of a given second order linear non-homogeneous differential equation wherein the given function f of x is an exponential function. Okay, and as always, if it's in second order, linear, and non-homogeneous, this is your general solution. Okay, where you have your u as your complementary integral function, and your v as your particular integral function. So let's just say your function is an exponential function, your f of x on the right. So you have d times e raised to rx. Your d is just a constant. So let your e raised to rx is equal to g of x. So basically, this is your f of x overall. Okay. So if you're going to read the conditions, it seems like you may not get what I'm trying to point out here. But let's take a look. If u, let's start with number one, does not contain g of x and x times g of x, then your v will be k times g of x. Second condition, if your u does contain g of x only, then you will have v is equal to kx times g of x. And lastly, if your u does contain both g of x and x times g of x, then you will have v is equal to kx squared times g of x. So to those who, let's just say confused to what I'm trying to point out, let me give an example. Let's just say I have, oops, no, this squared of y all over dx squared plus 2 dy all over dx plus 4y is equal to, let's just say 8 times e raised to 4x. Okay, so remember that the function here, e raised to rx, that would be your g of x. So basically, this is your g of x. Okay, so what I'm trying to point out here is that, do you think that this exponential function e raised to 4x will exist to the u function? Let me rephrase what I'm trying to point out. Basically, do you think that this function e raised to 4x will also exist at your u function? If it does exist, then what would be your v function? So for example, in your u function, after you found your u function, there is a e raised to 4x. So if there's e raised to 4x in your u function, then you're going to use the second condition, okay, which is v is equal to kx times your g of x, or e raised to 4x. Well, how about if, let's just say, in your u function, there is, let's say there is both e raised to 4x and x times e raised to 4x. So if that's the case, then you're going to use the third condition. So this would be v is equal to kx squared times e raised to 4x. Otherwise, if in the u function, there is no e raised to 4x and x times e raised to 4x, then you're going to use your first condition. So you will have v is equal to k times e raised to 4x. So let's try to do it in one example. Okay? So let me erase this one for a moment. So here, for example, we have 5d squared y all over dx squared minus 4 dy all over dx plus 5y is equal to 7e raised to 3x. Remember that this is your g of x. Okay? Okay, guys? So basically, later, at finding your v function, we're going to focus at this one. Okay? So now, first thing to do is you need to find your u function first. Okay? So remember that the general solution of a second order linear non-homogeneous is y is equal to u plus b. So let's start by finding your u. Okay? So remember, by finding your u is the same way on how would you find the general solution of a given second order homogeneous differential, second order linear homogeneous differential equation. So first, you're going to find the d operator. So we're going to substitute your d all over dx as your capital D. Okay? So you will have 5d squared y minus 4 dy plus 5y. That's it. Is equal to 7 times e raised to 3x. So after that, you're going to factor this out by y. So you will have quantity 5d squared minus 4d plus 5 times y. So this is now your d operator form. Okay? Then after that, we're going to substitute your d as your m. And in this expression, you're going to equate it to 0. So you will have 5m squared minus 4m plus 5 is equal to 0. So this is your auxiliary equation. Okay. To those who don't like to substitute d as with any letters, then it's okay. You can use d actually. Okay, like for example, instead of m, why not just use letter d instead? Like just copy this one. So 5d squared minus 4d. That's it. So it's up to you if you like to stay the letters as it is, then make this as your auxiliary equation. There's no problem for me. But if you're confused, or let's just say you don't want any complications, or you want to at least have a basic learning about this one, I suggest you should substitute different letters. So your D will be substitute as your M. Okay? So once again, guys, it's up to you if you like to substitute your D as your M or any letters, or you can just I'm sorry, or you can just let it be. Then equate that expression to 0. Okay? So anyways, let's go. Yeah, let's go back to the solution. Now, let's find our values of your M. So there are two ways if you're going to recall. Since it is a quadratic equation, you can either use any methods of factoring, or you can use quadratic formula. So for me, I'm going to use quadratic formula because this is not factorable. Okay? And since I'm going to use a quadratic formula, I'm going to use this technique. Okay? Which is comparing the values of your b squared and your 4ac. So let's start first with your b squared and your 4ac. Okay? Remember, in a quadratic expression, this is your a, this is your b, and this is your c. Now let's find your b squared. Your b is -4, right? So you have -4. Then your a is 5, and your c is 5. So get the values of these two terms. So b squared, so -4 squared is positive 16. 4ac, 4 times 5 times 5, this is 100. Now, if you're going to compare, your b squared is less than 4ac because 16 is less than 100. So, if the value of your b squared is less than 4ac, then expect that you will have two complex m values, okay, or two complex roots. So if you're going to have two complex roots, therefore, your u function will be quantity a times cosine of small bx plus b times sine of small bx times e raised to small ax, where your m value is equal to a plus or minus b times I. Okay? So make sure that after finding your m value, it should be at this format. Okay? So now let's what do you call this one? Since you already found the u function, however, we need to find your m values, so we can directly now use the quadratic formula. So let's recall that your quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Now let's substitute these letters. So your b is negative 4. So you have negative times negative 4. So remember, negative times negative is positive. So you will have 4. Plus or minus your b squared, which is 16. Minus your 4ac, which is 100. All over 2a, which is basically 2 times 5. So 2 times 5 is 10. So let's simplify further. So you will have 4 plus or minus the square root of negative 84 all over 10. And if you're going to simplify it even more, you will have m is equal to 4 plus or minus 2 times I times square root of 21. So if you want me to explain this, what do you call this one? Explain the way how I got 2i times square root of 21 from this one, then there's no problem for me. First, what I did here is I decompose this number into its 3 factors. So the 3 factors that I can think of is basically 2, 21, and negative 1. Ay, whoa. Wait, sorry. It's not actually 2, it's actually 4. Forgive me. So it's 4, 21, and negative 1. So how come I got 4, 21, and negative 1? Because these are the 3 factors that if you're going to multiply them together, the result is negative 4. 4 times 21, it's 84. Times negative 1, negative 84. Okay? So that's how I decompose them into 3 factors. Then after that, I'm going to separate these 3 numbers by their own square roots. Oh, wait, forgive me. Okay? By their own square roots. So I will have the square root of 4 times the square root of 21 times the square root of negative 1. So if you're going to recall, the square root of 4 is equal to 2. And the square root of negative 1 is equal to I, or your imaginary number. Therefore, we will have 2 times the square root of 21 times I. And let's bring up your I in front of your square root of 21. So we will have 2i times square root of 21. So that's how I got the answer. Okay. So let's copy the other term, which is 10. So 4 and positive or negative 2i square root of 21 and 10 are all divisible by 2. So meaning I can divide these terms, each of them by 2. So I will have 2 plus or minus I times square root of 21 all over 5. That's it. Okay. So it seems like we've already done because this is already in simplified form. However, remember that your m value should be in this format so that we can distinguish which one is your small a and which one is your small b. So therefore, I can decompose this whole fraction into 2, okay, separating them by separating them with their operations, which is plus or minus. So I will have 2/5 plus or minus I times square root of 21 all over 5. That's it. Again, I decompose this whole fraction into two fractions. Okay? So therefore, I have the first fraction, 2/5, plus or minus the second fraction, I times square root of 21 all over 5. So that's it. So this is now my m values, which is in the same format. So now I can clearly tell which one is my A and which one is my B. So this one is my small a, and this one is my small b. Because remember, your small b is partnered with your I. So since we have your I here, and we have square root of 21 all over 5, therefore your b is square root of 21 all over 5. Now, we have also a and your small b included in the function. That's it. Now, we can substitute. So, quantity a times cosine of your b, which is square root of 21 all over 5 times x plus b times sine of square root of 21 all over 5 times x times e raised to your a, which is 2/5 of x. So this is now your u function. Now, let's now proceed to your v function. So for your v function, you're going to observe your function in here. Okay? So your function here on the right side is 7 times e raised to 3x. Okay? So remember, if we have a exponential function, you're going to focus at this part. Okay? Your g of x, which is your e raised to 3x. Now, do you think that your g of x, which is your e raised to 3, do you think that your g of x or your e raised to 3x exists in your u function? Does it exist in your u function? So let's take a look. So in your u function, we have cosine, sine, and your e. However, in this e, you have 2/5 times x as the exponent for your e. So there is no e raised to 3x here. Okay, there is no e raised to 3x. So if there's no e raised to 3x, therefore, wait, forgive me. Since there's no e raised to 3x, and there's also no x times e raised to 3x, so you're going to use the first condition. If your u does not contain g of x, which is your e raised to 3x, and x times g of x or x times e raised to 3x, okay? So if there is no e raised to 3x and x times e raised to 3x, then you're going to use your v as this one. So therefore, your v is equal to k times g of x or e raised to 3x. So that will be now your v, k times e raised to 3x. So once again, since there's no x times e raised to 3x and e raised to 3x, therefore your v will be k times e raised to 3x. Now, what we're going to do is we will substitute your v in your y. Okay, so let me copy the d operator form. Once again, where are we going to substitute the v? We're going to substitute the v in the what? In the y of your d operator form, which is this one. So, okay, this will be basically a v. So we will have 5d squared minus 4d plus 5 times v. Or you can just directly substitute k times e raised to 3x. Okay, so we can just have ke raised to 3x. So that's it. So after that, we can simply distribute this in this expression. So we will have 5d squared of ke raised to 3x minus 4d of ke raised to 3x plus 5 times ke raised to 3x. Then let's copy the other term, which is 7e raised to 3x. Remember that your d is equal to d all over dx. So that means you're basically getting the derivative. So since we have this squared, so we will have d squared all over dx squared of ke raised to, raised to 3x. And here we have 4d, or just simply as 4 times d all over dx times ke raised to 3x plus, yeah, the other terms. Now, after that, forgive me. So now after that, we're going to get the derivative for these first two terms. So for the first two terms here, since we have d squared all over dx squared of ke raised to 3x, it means that we're going to get the second derivative of ke raised to 3x. So the second derivative for ke raised to 3x is 9 times ke raised to 3x. Okay? The next, here, we have d all over dx, so that means we're just going to get the first derivative only. So by getting the derivative for this one, so we will have 3ke raised to 3x. So let's copy the other terms. So after that, we're now going to find the value of your k. So, or basically, let's find your k. Not value, but, basically, let's find your k. All right? So what we're going to do now is we will simplify further. So let's distribute 5 to 9ke raised to 3x. So we will have 45ke raised to 3x. Then negative 4 times 3ke raised to 3x. So we have negative 12 times ke raised to 3x. Then the rest of the terms as well. So now let's simplify. Since these three terms are similar, we can add them together. So 45 ke raised to 3x minus 12 ke raised to 3x plus 5 ke raised to 3x is basically 38 ke raised to 3x. So after that, let's now find the k. So we will divide both sides by 38e raised to 3x. So what happens? This would be cancelled out. And on the right side, the e raised to 3x's will be cancelled out. Hence, you will have k is equal to 7 all over 38. So going back to the formula of your v, write your v is equal to k e raised to 3x, right? Am I correct? Okay. Since your k is 7 all over 38, so we will have v is equal to 7 all over 38 times e raised to 3x. So that is now your v function. So therefore, what would be now your final answer? Your final answer, since it is in format of y is equal to u plus v, therefore we will have y is equal to your u, which is quantity, a times cosine of square root of 21 all over 5 times x plus b times sine of square root of 21 all over 5 times x times e raised to 2 all over 5 times x. Then plus your v, which is 7 all over 38 times e raised to 3x. So this is now your general solution. So basically that's it. That's how you find the general solution of a, what do you call this one? Wait, let me fix this one. Okay, this is general solution. So yeah, basically that's how you find the general solution, okay, of a given second order linear non-homogeneous differential equation wherein the function on the right side is an exponential function. So yeah, basically that's it. That's how you find a general solution, at least for this case. Okay. For getting the particular solution is the same way on how we find the particular solution for a given second order linear differential equations. Okay. So for now, at least I already gave you the idea on how would you get the general solution for this one. Okay, so that is all.